Hey everybody, welcome to another Avalanche Developer Community Call. I am Gabriel Cardona, a developer evangelist here at Ava Labs, and I'm very excited today to be joined as always by these amazing engineers from the platform team. We have Patrick O'Grady, Stephen Budoff, and Aaron Buchwald. Hello, gentlemen. Thank you for joining me.
Hey, Gabriel. How's it going?
Thank you, sir.
Hey.
Yeah, going great. So this is a bi-weekly chance for the developer community call to get FaceTime with the amazing Ava Labs engineering team. This week, as you can see, as usual, we have the platform team, but we are open to having other engineering teams join the call in the future if the community is interested in that, and I suspect there is a lot of interest in that. Today, we are going to be talking about the new Cortina 3 update. We're also going to be talking about some updated Grafana dashboards, a new Postman Collection build, and then also kicking off a hackathon in Hong Kong. We'll be talking about that more later when I come back on stage, but for now, I'm going to pass the microphone to Pog so that he can cover all the exciting stuff on the platform team. Take it away, gentlemen.
Yep, a lot of stuff going on as usual. So first off, we'll dig into Cortina 3, which should launch hopefully in the next 24 to 48 hours. So I'll turn that over to Steven, and I'll pull up some stuff on my side to kind of visualize what's coming here.
Yeah, so I've kind of broken down mentally Cortina 3 into 3 different sections. So one section, which is important for everyone running AvalancheGo nodes to understand, is there's some changes to a couple key metrics and also some configs around the API that are important. So we introduced an allowed hosts flag specifically. So if anyone is expecting to hit any AvalancheGo served APIs from any hosts other than IP literals or localhost, then you'll have to manually set that flag in AvalancheGo. This is basically just a best practice in other servers to do this. So we added that in here, but for anyone running like API servers specifically, this is a really important call out to know for this release. We also changed a couple metrics around percents of stake connected for better like monitoring on subnets. And also we added in as an action item from one of our prior calls, I think, was separating out health checks. So now if you're running a subnet, you can specify in the health API specifically the tag related to your subnet, which is your subnet ID. And so that filters out all of your health check requests specific to your subnet. So if you have like multiple subnets running and one of your subnets goes unhealthy, and you don't want that to impact like API load balancing for a different subnet, then this is really useful for handling that logic for your load balancers and various other more complex configurations of AvalancheGo nodes. So that's a couple important call outs on the API side. We've also been cleaning up a couple things on the networking side. So some of the improvements or some of the bottlenecks that we found in our HyperSDK playing around with, we're trying to bring back those improvements into AvalancheGo, see kind of like more of the real and improvements that research is coming to. So we improved some of the push and pull based polling gossip. So that should reduce bandwidth during high load situations on the network. And then we also cleaned up a couple of P2P proto messages for post Cortina, which is going to allow us to further improve some bandwidth, further introduce some bandwidth optimizations that we've played around with. So those are the APIs and the networking side. And then I think the major third thing in this is continuing on with warp improvements. So we had when digging into warp, we found that the get validator set was still returning some incorrect stuff, which isn't being used yet in any network. So it's not really a major issue, but that should be patched in this release, and then hopefully in the next release we'll have some further optimizations in this area as well. So I think those are kind of the 3 major things that are part of this release. Yeah, I don't know if there's anyone else.
Yeah, I wanted to reemphasize two of those. So actually, another 3 of those. So on the push query stuff, so to provide some context here, so to Steven, this is like basic stuff, right? For people that are probably listening to this, are like, what the hell is a push query? So which was me at various points in time. So if you're feeling that way, it's not nothing crazy. So the way that Avalanche works on the consensus layer is there are 2 types of queries it will do, one called a push query and one called a pull query. When a node verifies a block for the first time previously, it would send a push query to 10 stake-weighted peers, basically, or stake-weighted validators, not peers, with the block bytes that it just verified. Now, you may say, well, why do that? Well, it helps block data get around the network quicker because you're optimistically pushing data to people. However, what we found almost always was that this mechanism had a lot of useless byte overhead. So when we did that first query, almost always the recipient of that query would already have the block bytes we're sending to them because it's stake weighted, right? So everyone's already sending them a bunch of block bytes, or they maybe already produced the block because block production is also stake weighted. And so the change is only now we do a push query if you built the block, and then all queries after that are just pull queries, which basically says, I'm going to query, let's say I produced a block or I have the block. I now pull query you to say, like, what's your preference? And I'll say, this is my preference, this container ID. You're going to be like, I don't have that container ID. So then I go fetch it from you, rather than you optimistically just pushing it the first time. And so we think that this will significantly reduce the amount of bandwidth actually on the network, and it very much reduce it in a high throughput use case. So the downside of this, right, everything has a trade-off, is that technically people may get the block slightly slower than they did previously because it's not optimistically being pushed to them. They have to go fetch it. But we think the net benefit of this with the reduced bandwidth vastly outweighs that potentially slight delay there. It could even be faster based on how things are going because you're sending less data in. But that's the background on that one. The second one with the BLS key bug, as Stephen mentioned, there's nothing in production using this, fortunately, so there's no real issue there. But the big thing to call out is that it basically could have prevented a subnet from verifying a new warp message. So the key would show up as nil rather than like being the incorrect key of like someone else. And so it could cause a liveness issue with validating warp messages, but it would not cause a safety issue. So like you would not start to see like random keys showed up that if they signed and didn't have any stake weight, they could now like send a message through. So it's very important to call that distinction out. Lastly, the other change I'm really excited about that we got in was a MerkleDB related change with the version DB. So when we were initially developing the MerkleDB, the team added a layer between the Merkle context and the actual database to provide write atomicity, or so that team thought. But it was unnecessary because the batches that the databases we support already provide write atomicity. So we were basically doing a redundant or like extra copy every single time. So we would take the Merkle context, batch that out to the version DB, and then batch that version DB out to the database. So we just removed that intermediate step. So that should reduce memory usage on the order of number of keys, as well as basically make it faster. Because we can just use the database batch directly. And so we just skip a whole intermediate step. So I think that, pretty good. I'll now turn it over to Aaron to discuss changes related to Core ETH in Cortina 3.
The major change going into Core ETH and Cortina 3 has been migrating all of the changes in from Go Ethereum through V1.11.4. So these are a huge amount of changes that's coming in from Go Ethereum, and we've put a lot of work into verifying how all of the changes fit into Core ETH. So that is also included in AvalancheGo V1.10.3. So you'll see that there. Additionally, the biggest thing coming from the EVM side that'll be released in the next week or two is we've also been further working on improving the developer experience for subnet EVM precompiled developers. As it is right now, if you are trying to implement your own precompile in subnet EVM, it requires that you actually fork the subnet EVM repo and then sync back changes from upstream into your repo. And this can lead to a lot more work in order to maintain that. And so what we've decided to do in order to make that development experience significantly easier is actually make it so you can develop your own repo, which we're calling, at least in our example, precompile VM, where the only change that you have to make, the only code that you have to maintain is simply your own precompiles and then importing subnet EVM and registering your own precompiles there. So this drastically reduces the maintenance burden of anybody that wants to develop their own precompiles. So where previously you would maintain a complete fork of subnet EVM and have to merge all of the upstream changes in, and then also build the actual precompiles that you care about the most. Now, all that you'll have to do is build out the precompiles, register, import subnet EVM, register it, and have a plugin folder with main.go in it in the exact same way in order to run the RPC chain VM server that AvalancheGo relies on in order to talk to the VM. And then it'll make the precompiles available as well. So this is just drastically improving the development experience for anybody that wants to build precompiles on subnet EVM. And I think we ran into some issues as we were publishing some of the contracts in subnet EVM in order to make it easier and reduce the code duplication. But it should be coming out either this week or next. And we've been working on this for a long time. And we're really excited because we've been talking to our DevRel team as well. I know Gabriel was taking a look at it, and I think Martin's been very, very eager to integrate this as well into some of the new resources, educational resources that we're putting out, so people can have a really easy time and a very easy walkthrough tutorial experience when it comes to building out new precompiles. That's pretty much it on the EVM side. Turn it back to Patrick.
Yeah, I think the other thing that's really coming there, and we've alluded to this a number of times, is the teleporter work with Avalanche warp messaging. And so, as Steven mentioned, we've been digging through that, and a lot of work is currently going into the subnet EVM to enable teleporter, which is the Avalanche warp messaging integration for EVMs. And so through that, we've been doing a bunch of benchmarking to AvalancheGo to understand like where the bottlenecks are on the warp verification path, and have already discovered like a number of what we consider to be straightforward changes to the core of things to really non-trivially speed up the verification process. And so people have asked us like, oh, you mentioned teleporter here, teleporter there. It's like we get close to it, it works, and then we're like, oh shit, we could also reduce that 50%. Like we should probably do that before we get it out the door. And the reason why we're spending this time is because at the end of the day, the subnet EVM has to apply a gas cost to the warp verification. And if the overhead or like time required to verify one of these messages is too high, that just means the gas cost is going to be higher. And so developers obviously are going to prefer as low a gas cost as possible, but not so low that it like underprices the resource, because then you can have a DOS attack. So we're trying to optimize things enough so that the gas price will be lower, but not so low that it's below the actual cost of the operation.
Yeah, if you're curious about this, you can also look at, I don't know how many people will do this, but you can also look in core/VM/contracts_test.go in subnet EVM. The same is present in Go Ethereum as well as Core ETH. And this shows you the exact benchmarks that are used in order to benchmark the existing precompiles. So what we've actually gone ahead and done is build the exact same system for our unit tests and benchmarks for the new precompiles that we're adding in. So we can have the exact same comparison and make sure that the amount of gas that we're choosing to charge is commensurate with the computation time and resources allocated in order to perform the verification of warp messages and the execution of those precompiles.
Yep. Yeah. So this release should come out, like I said, in the next 24 to 48 hours. So we're just doing some final checks on there. I will give one shout out. We were testing it a little bit yesterday, and the Hubble team noticed a regression of the API and let us know right away, and that prevented potentially introducing a regression into this release. So shout out to that team for letting us know and paying really close attention to the API format. So thank you for that. So yeah, with that, we'll now go into some of the HyperSDK latest. So some folks on Twitter yesterday were noticing that they basically found my debugging journal, what I'll call it. And so what I typically do while kind of doing some research is I will post intermediate Prometheus dashboards while I'm working on it. So if you follow like the latest PRs on whoa, sorry about that. Follow the latest PRs on HyperSDK. You'll see a number of different logs and stats and everything like that. And so what I'm currently focused on is the over 50,000 TPS use case in a distributed cluster right now. So if you recall, I'm going to share a different page here. One second. Summit 2023. All right. So if you recall from my summit presentation, if you don't recall this, it's now uploaded. So like, feel free to check it out. You can read it and kind of hear me explain what we're doing here. But long story short, we're trying to break apart the block build process so that we can start to verify the block while we're still building it. This will increase the throughput because instead of having the network where you build and then verify, instead now we'll be able to like finish verification only like 1 or 2 time steps after the build process finishes, rather than number of time steps that it actually took to build that block plus network latency. But doing this is a little nuanced. There's a lot of new dimensions that it adds to the chain related to like how you actually distribute these pieces, like how you actually build effectively to maximize your throughput, how like the network layer is optimized to support this. And so a lot of what I'm doing here is focused on that effort. So in my testing, we've now been able to reach on 6 C5 4X larges 70,000 TPS. The goal we had for like productionizing this was about 50,000. So we're now in bonus category, I would say, for this instance class. However, there's one last like bug or kind of nuance that I'm trying to dig into, and that's what a lot of this you'll see is periodically the networking layer will leave. Let me see if I can zoom in here. Will leave what I call TX blocks missing. So what that means is like in that page I showed previously, we distribute these chunks during the build process. And occasionally some nodes don't get all these chunks by the time that verification is supposed to start. And so I'm going to take a slight digression to kind of explain a little bit of how like the consensus and like verification process actually works behind the scenes, because for VM builders, this is like super critical knowledge to really have. So AvalancheGo has a number of phases of the block process. So there's what we'll call parse, then there's verify, and then you either accept or reject. Now, AvalancheGo or your node will not actually start to vote on a block until it's verified. And the reason for that is that you don't want to like start to verify stuff that isn't valid, which could cause a safety failure or something like that based on typically how virtual machines are designed. You could change this if you wanted to, but I'm not going to get into that right now.
I really want to, but anyway.
All right, Steven can get into that after I finish this explanation, because I think it's a very interesting topic as like VM building goes. And some people have played around with this, so it is a good conversation. But nonetheless, assume for now that like you parse a block, so that's like taking the bytes, turning it into a block, making sure it's actually a valid block. Once it's valid, you then verify it, so you execute the state transitions and make sure that it's like a valid block, so like transactions aren't creating money out of thin air. And then once that happens, you start to vote, and you either accept or reject. Well, that means, though, that all the other validators in the network need to finish verification, or like some large percentage of them need to finish verification by stake weight to be able to actually start to accept blocks for everyone else. So let's say that almost everyone's got the block verified, but there's a few stragglers. Well, hate to break it to you, but your network's now going to stall. Or if the producer or if the Snowman++ says that the next producer is someone that's a straggler, Well, now the network's going to super stall because there won't be new blocks either because they haven't finished verification. So it's really important that these like chunks can be distributed very quickly throughout the network, very reliably through the network, and that other nodes can actually verify them quickly to ensure stable block production. But there's a lot of protection mechanisms built into AvalancheGo, particularly on the network layer to prevent DOS and Sybil attacks against the node that act against this because they're not used to a virtual machine sending tens of megabytes a second of throughput to other peers. In most cases, that would be considered probably a DOS attack. So what I've had to do is kind of reverse engineer a little bit of like how AvalancheGo actually does all of this block distribution and data distribution throughout the network and figure out where different bottlenecks are that actually prevent these blocks from sometimes getting stuck. And so it's a complex problem because sometimes it's not even a software issue at all. It ends up being like a hardware issue on the cloud you're using, or like, you know, transient instability on the networking layer that you're actually using as well. So we're also adding a lot of tooling to help us better diagnose where different bottlenecks may actually pop up. So what this ends up amounting to is really that the build process gets what I call spiky. So spiky here, and these are all public PRs, so you can definitely check them out, means, excuse me, there we go, so good one. That relatively
man some water.
Yeah, finally cleared my throat. All right, I don't know what was up with that. But what ends up happening is that blocks occasionally, like it will flow very, very smoothly, very, exactly how you want it to. And then all of a sudden, one node will just not get the TX blocks that it expects for some number of seconds. They'll be missing something like that. And so what will end up happening is that node will then not start to vote. And then in cases where it's supposed to be the next producer, the network just like sputters. And so you see like really nice, stable, TPS, and then all of a sudden nothing for like, 1 second or 2 seconds, then back up to whatever it was doing, then down, then back up. And so we're trying to fix that particular issue. It only happens at the edge. So like when you really start to push the TPS, and it's clear that I'm pushing like the networking a bit above what it's typically used to. And so, so I'm just playing around and experimenting with that. But as Stephen mentioned, all of these changes are the issues that we find make their way back into AvalancheGo for any virtual machine developer to end up using, for their own high throughput use case. And so once I figure this out, as a reminder, we're going to go right into programs. So programs are like smart contracts, basically, for the HyperSDK, and that'll allow you to actually deploy custom contracts written in Rust, C++, C, or TinyGo, hopefully, and then assembly script. So, it's going. So we're really excited with it, and a lot of people have also express some interest in playing around with it once we get it a little bit more production ready. But I will turn it back to Stephen for a brief aside on deferred verification.
Yeah, no, I mean, there's a bunch of kind of like fun optimizations that the consensus code can still undergo, and I've been trying to get them in as time goes on. So watch out for some of those improvements. We'll probably be modifying the chip message in an upcoming release to kind of further optimize some of the vote bubbling logic and things like that. But yeah, this specific thing is the invariant in the consensus code is essentially that a node does not vote for something that is invalid. So you don't want to like push people in the network towards something that is invalid, but that does not necessarily mean that someone when someone votes for something that you have to have already verified it in order to like apply that vote. So essentially what we can do is defer vote processing until you are put in the position where you would push people towards that thing. At that point, you can actually verify that it is valid as far as you're concerned, and then move along with preferring it. So essentially, rather than verifying blocks when you insert them into consensus, you can defer the verification until you prefer it, which for most cases is probably not a huge improvement, but for some cases it probably is, especially with the P chain, with how we do like Oracle blocks on like removal of like the proposers. We'll probably be able to cut out like quite a decent number of like unnecessary block verifications and things like that. So yeah, should be pretty cool. There's definitely a bunch of complexity because currently the consensus code does not gracefully handle removal of stuff unless it is either accepted or rejected. And so you don't want to get into a position where there's definitely complexity. It's not like a very easy drop-in improvement, which is obviously why it's not done yet. But yeah, but it's definitely a very exciting one for me. I think we'll probably end up splitting out the verify into like a couple different steps of verification. So we'll probably have like a pre-verify step for things like the proposer VM or any like soft or like not soft, like fast verification can be done. And then we have like another verify that's like the deep verify to fully verify the block, so that we can like separate that out. We do expect VMs to be able to what we call syntactically verify blocks during parse. So in addition to just actually being able to understand the bytes, you can introduce arbitrary numbers of constraints inside the parse function for like any arbitrary formatting restrictions. But there's no guarantee that that block is parsed in any specific order for the consensus code. So you can't depend on any state during that part. But we can, with like any like other breakdowns of verification, have some guarantees around what state is available to the underlying VM. And so then you can optimize that out. But anyways, very much aside, but this is the kind of stuff that I really like talking about. So
the next step of what I have is playing on that, which is if you want to run it back turbo, you basically just assume that because the verification is deterministic, that really the consensus process just needs to agree on the data in the block. And that like if you agree on the data in the block, that you can execute after the fact or even after you've accepted it, if you handle failures of those transactions and have some way to like prevent some form of DOS of like stuffing blocks full of transactions that can't pay fees. But if you do that, then you can totally break apart like the verification process and like what we'll call like super batching, where you can just verify a number of blocks all at once in parallel rather than like, having like a big parallel script rather than trying to like verify these very short segment windows where you can't take advantage of that full parallelism, especially if you break apart like the Merkle root generation to being some number of those blocks. Then you can really start to get some large benefits, but it makes like the state syncing process much more complicated.
Yeah, one thing you can do here that I've thought about is like essentially having a lag for like the expected execution results of stuff. So you can essentially run two parallel chains where you have like the chain for like managing data payments and then the chain with like execution. And the execution chain has the ability to like pay out to the data chain, but there's some lag. So you have like some like lag where you expect the execution to be able to keep up, because you can't like just have it run as fast as possible on both, because the execution is always going to be slower than the data and you need to like bring that information back in somehow. But you can definitely like completely separate it from the verification process, which is interesting.
Yeah, you end up running into issues with the build if you do that, because like you're bounded by how quickly you can still build, right? So like if you have this super delayed verification process,
but
well, in that case, like the next builder can't actually like produce a block, which ends up being an issue in terms of like actually achieving throughput.
I don't think that the builder would have to actually have executed all of the executions. You just have to have executed up to the lag executions, which is expected for everyone.
I guess Yeah, I guess the conversation ends up becoming like how you can do that while still preventing like reasonable DOS on that if you're not actually doing some check on the transactions as a builder, if you're like stuffing in conflicting things, because you could argue
Because
it could follow that, for example, if you're building and you build something that has invalid transactions in it, other nodes on the network, at least in Avalanche, could start to like decrement your uptime because the block building process is attributable. So you could like actually penalize the builder for that. Or deduct from like their builder account if like you had to like make it basically fully attributable.
yeah, I mean, basically the requirement for both building and verifying should be the same, unless you want to have a separated proposer builder mechanism, right? And like the requirement should be that you have kept up to date with the data accounts of this like subchain, and then you have kept up to date with the lag execution chain. And then that's all you should need, because when you're putting in new transactions, all you're charging for is the data. And then when you actually go to execute them is when you're actually like determining the validity and doing more on the execution based account, including transfers to the data on the lag. Anyways, yeah, complex conversation for sure. Something that I have definitely thought about.
HyperSDK plus is what we'll call it, I guess. Yeah. All right, Aaron, what were you gonna say?
It ends up being really similar to some of the stuff that the folks from DM, which is the term I always use to describe Sui and Aptos, just the folks from DM do inside of their mempool, because what they actually want to do is sort of come to consensus on or make sure that their mempool is aligned for all of the nodes in the network, and then come to consensus on, okay, this will actually be the block. And so what that forces them to do is they need to have some guarantee that all of those transactions will actually be valid, because they're going to produce those blocks and sort of defer the actual execution of it after they've already done most of the work of ordering things, which creates this sort of a funny potential DOS vector, which is exactly where the decoupling happens here, which is essentially you want to make sure that when you're ordering transactions, you're doing some work, and you need to make sure that you're actually charging for it or capable of charging for it. So the decoupling that we're doing here is really just make sure that you can charge for whatever work that you're doing, and then defer the actual work until later, so that you can essentially do everything that all of the expensive stuff of execution asynchronous, and that makes things a lot more efficient. And so what they actually do, I think Stephen and I learned last week or the week before, is they actually sort of break up into individual slots how much work anyone can do in an individual one of those slots, so that there's a cap on how many transactions from an individual account could be spending in an individual slot, so that nobody can overspend, and there's a cap on how many transactions could end up not getting fully paid for, so that when you go into the next slot, you guarantee, okay, I've actually fully finished executing all of this stuff, and then I can sort of refresh and say, this is how much work I could be expected to pay in this slot.
Yeah, I think generally my comment for high performance blockchains is that DOS resilience has to be very carefully considered. And if you're just pushing for straight speed, you can absolutely blow the doors off of things. But if you are like, I want like really fast, but also not like some people to be able to like bring my network down by like doing some like thing, then it becomes more interesting and difficult problem. So whenever people talk about like high performance blockchains, I'm always like, so how do they prevent spam? Yeah, anyways, so very interesting.
Yeah, like in this case, for example, in the stuff we've been doing in the HyperSDK, like because people gossip these mini blocks, like what mechanisms do you have to prevent like that producer just like spewing 1,000 of these mini blocks to you, and then you trying to verify all 1,000? Or like, how do you prevent people that aren't producers spewing you blocks? Because like, right, they're optimistically sending you chunks before the block's even complete. So if you have to be pretty advanced when thinking about like how you actually prevent against these things. Otherwise, as soon as you go live, one person has one idea and they just, as Stephen says, blow the doors off it, I guess. But yeah, so that was fun. Go back to that again at the end, but I'm going to bring it back to Gabriel now to talk a bit about some other DevRel related efforts. Then we'll come back to questions. Yeah.
Excellent. Thank you, gentlemen. So yeah, we just have 3 topics and then we're going to come back to questions. If you are watching this in real time right now and you're on our YouTube live stream, you can see on the right there's a chat box. Please take this opportunity to drop any questions you have for the platform team in over the next few minutes while I cover these DevRel issues, and then we're going to swing back and wrap it up. So if you have any questions, this is your chance to get them in right now. Okay, so the first thing I want to do is mention a new Postman Collection build, version 1.6.1. So Postman is this really great tool which allows you to quickly test APIs and build out REST interfaces. And we've had an extensive Postman collection for as long as I've been on the team. I think I created it just a couple months after joining, and it's comprehensive. It covers 100% of the JSON RPC, which is on the AvalancheGo full node. Recently, there were a couple updates, and so we pushed out a new build. So the things to be looking for in 1.6.1 are we added 3 new endpoints to the AVM collection. So there's now get block by height, and get height. We also added a couple of new environment variables. There's the Xchain block ID and the Xchain block height. But the main change in this is that we deprecated a bunch of APIs. So we deprecated all of the IPCS APIs, for IPCS, published blockchain, unpublished blockchain, etc. We also deprecated all of the key store APIs. So we're strongly advocating that people do not use their full node as a hot wallet and store keys on there. So now the key store APIs have all been deprecated. We also deprecated several of the AVM APIs. There's over a dozen, so I won't read them all off. And then we also deprecated about the same number of platform APIs. And so in the past, it was kind of challenging to know which endpoints were deprecated because JSON does not support comments. So it wasn't easy to add a comment into the JSON body, the post body, to say, hey, this is deprecated. But just recently, Postman allows comments in the JSON post body. So now it's very clear we made the name, whatever it is, avm.send, and then in capitals we'll say deprecated, and then in the actual JSON post body there's an actual comment there that says deprecated. And then as soon as those are actually removed from AvalancheGo, we'll remove them also from the Postman collection. So I believe Kyle is going to be sharing that link into the live stream. You guys can check it out. Again, it's the Postman collection version 1.6.1. So that's one announcement. The next announcement is, so as you guys have probably been noticing from following online, the developer relations squad has recently grown quite aggressively. We've recently added 4 new people to the team, and we're still hiring. So if you guys are interested in developer relations, please go check out our online board of jobs. We're hiring across the board right now on the developer relations squad. And so as the team starts growing and taking shape, there's a big initiative that we want to start focusing on is kicking off a new set of hackathons. And so today I actually have 2 different hackathons that I'm going to be announcing. The first one we have coming up is in collaboration with Blockchain Academy and the top technical universities in Hong Kong. And in this 6-week boot camp and hackathon, students will be able to be the first ones to test Avalanche Academy in the boot camp and then develop into different tracks, including custom EVM precompiles, app-specific subnets, and custom VMs. And so you can also sign up, and it's open for free and for all. So again, be one of the first people to test Avalanche Academy and our first hackathon of the new set coming up. So there's a URL here, Talentre, TALENTRE.academy/hackathon. Again, I think Kyle is going to share that link into the live stream. So as you can see, we're hinting here at the Avalanche Academy. So the Avalanche Academy is something we've been tossing the idea around for a while, more of a formalized learning environment where people can become accredited Avalanche developers. And it's something that is now finally coming into focus. And so if you sign up for this hackathon in Hong Kong, which is free and it's open to everybody, you will be one of the first people to be able to try that out. And then the second this is actually Hackerspace, is the Good Morning Vietnam Hackerspace. So Avalanche is partnering directly with the GM Vietnam Hackerspace as the official hackathon side of Good Morning Vietnam. This event aims to showcase Vietnam's tech talent and offers multiple innovation tracks to explore. participants in the Avalanche track will have free range to decide how they want to build their solution for DeFi, NFTs, gaming, infrastructure, tooling, or any other application. And all developers are encouraged to apply for the GM Vietnam Hackerspace. Whether you have zero experience or you consider yourself a coding veteran, our program is designed to cater to all skill levels. And the hackathon will be conducted entirely online. So you can go see gmvietnam.io/hackerspace for all details on the timeline, the mentors, the workshop, etc. And I want to give a quick shout out to Usman Asim. His Twitter is ASIM Files, Asim Files. Also Megan Fitzgerald, her Twitter is MEAG Fitzgerald, FITZGERALD. And then Martin Eckhart, MARTIN_ECKARDT is his Twitter. Those are just three of the amazing new developer relations engineers, and they're putting a lot of energy into the announcements I just made, which is the hackathon in Hong Kong, the Avalanche Academy, and then the Good Morning Vietnam. So I just want to give a shout out to those three. So that is the three news items that I wanted to drop for the Developer Relations Squad. And I'm now going to pass the mic back to Pog for final thoughts and signing off.
I think there's one or two questions I did want to answer. First one comes from Jamari about Glacier. So Glacier, for people that aren't aware, is basically a higher level API that ingests all the data across all subnets as well as the primary network, so C, X, and P chain. If you're building a wallet like Core, for example, it uses Glacier for everything. And so we've been internally dogfooding Glacier for some number of months now and continue to push forward what it should be capable of doing and plan to add a number of really cool features in the next few months. But his question was he'd like to clarify, would like clarification on how to mitigate rate limiting on Glacier and best practices for leveraging. Are there any API keys needed? So this is a common question we've gotten from a number of different people on the public API, both on Glacier and on the RPCs for the nodes. Right now, there are public rate limits imposed on everything, and that's standard across everyone. No one gets like special treatment or exceptions in that way, other than like different partners and stuff that want to use Avalanche data for some sort of product or service. But in the very near future, hopefully the next few months, we're going to add a self-service platform for you to provision and pay for advanced usage API keys, so that you can get larger access requirements for different things. And so that will allow people to build much more advanced data gathering services and products on things, while also ensuring that the platform itself stays stable for everyone else that's still using that platform. That's usually the big problem and concern with things, right? It's like it's a shared resource. So if the rate limits aren't correctly tuned, you can affect everybody else. And so the hope is that by allowing this sort of API key mechanism, we'll let people have advanced usage without bringing down other traffic. So yeah, good question.
I've been looking forward to that API token, like actual like cost of this.
Yeah. The other thing that's interesting is that that will allow us to do a number of other things, like by registering accounts and things that we can provide like updates for, so you don't have to pull everything. But I guess the complexity for us has been that normally when someone rolls out like API key metering, right, it's on like some new API that like no one's using, and you can just like kind of spin it up and then like scale it up as your traffic scales. Like our daily traffic to endpoints maintained by Ava Labs is like over a couple billion, so it's tough to just like throw a service at it and like try to hook it up, I guess. And so the challenge has been making sure that the metering is scalable, because, for example, if on like every API request you like query a database to see, do you have room for this request? Well, that could take longer than just resolving the raw request. So we also don't want to like double or triple the latency, especially if cached requests, if you have to like now run back to some database somewhere if the data is already cached at the edge. So doing so in a way that doesn't actually like destroy the experience people are currently getting is a little bit more nuanced. Yeah. The other question was a question I had for myself because I wanted to elaborate on this, which is like, hey, Patrick, like how would programs look in the HyperSDK? So as we're thinking about like building a new programming mechanism or like kind of deployable program or permissionless deployment of programs from scratch, there's a lot of like really interesting conversations to have about like exactly how the program structure will work. So, you know, there's a lot of different types of calls, for example, in the EVM. You have like call, delegate call, like you have all these different, the structs, like you have a bunch of different like nuanced ways that these contracts can interact with each other. You have the ability for like contracts in delegate call to like assume the identity of other callers and like how it all interacts with each other. And you have like some number of like some amount of like capabilities built into the opcode model underneath that lets you do other work. So like, for example, like opcodes that let you do precompiles, opcodes that let you, you know, do more complex contract things. And so what we're currently evaluating is like how complex to make those lower level opcodes and how much to actually build in to the core rather than just making them contracts, right? So like you could have an opcode, for example, that does a transfer. Should you have an opcode that does a transfer, or should you instead require a program to be deployed that lets you facilitate a transfer? Now, the reason why you may want to have transfers built in is that you could have like some constraint checking at the end of a program execution to make sure that if balances are actually managed by the virtual machine itself, that like you don't have a leakage of balance. Like, oh, you know, I performed this like swap and I now have way less balance than I thought. I should just revert the transaction because there's probably a bug in that contract. So it can be a really cool way to like have runtime checks without actually having to like prove or like have some advanced prover on the underlying bytecode. The downside though is then it becomes less flexible, right? Like if you want to like extend what it means to have a balance, you know, you end up getting into a rough spot. And so I'm hoping to write kind of a thread on some of the stuff that we want to do in terms of like actual like on the fly runtime verifications that users should have the ability to do in the next few weeks. But you know, I think long story short, what I'm leaning to is having very simple capabilities on chain and then like trying to deploy almost every advanced capability using actual contracts to minimize the basically the optimization footprint that the VM will have to worry about. At least that's been my learnings from playing around with the EVM so far. So cool. I think that's it in terms of questions that we have. I don't know if there's any other questions Stephen or Aaron want to ask themselves that they wanted to elaborate on, but if not, I think that's it.
I'll leave the third person to you, Patrick.
Yeah, I ask myself a lot of questions every day, but I typically keep it all up here.
I keep it in my own head too. Yeah. No one needs to or should hear that. That's yeah.
Okay, so then let's pass around the mic and get last minute thoughts, and then if you want to share a social channel where people can find you, Stephen.
Last thoughts. Yeah, just trying to get the release out today. As we mentioned, we tried yesterday and we rolled it forward and then we rolled it back. So doing another stab today. Should be good this time though. Fingers crossed. But yeah, so just looking forward to that. Socials, you can't find me on social media. I'm confident about it, but if you really want to, I'm technically at Stephen Budolf on Twitter. I might tweet once in you know, a blue moon, literally. But yeah.
Awesome. Thank you, sir. Aaron?
Thanks everybody again for coming. Another shout out to Hubble for reporting that regression to us so quickly. Really appreciate that. That helped us to roll back really quickly yesterday. Also, I see Kit Sturgeon is here, so shout out to him as well. I see there was a question about talking about verified as well. So huge shout out to all the people building VMs on Avalanche. Really excited to see what everybody builds. And yeah, thanks everybody.
Social channels or no?
Oh, Aaron Buchwald is just my name on Twitter, and that's the main one to find me at.
Thank you, sir. Patrick.
Thanks, Gabriel.
Yeah, I got to figure out this sputtery block producing stuff. So hopefully that gets resolved quickly because it's driving me insane. And then in terms of social channels, I actually release or launch my own website earlier this week with great help from ChatGPT to help get that off the ground, particularly the CSS styling front. But you can find that at patricko'grady.xyz. And that I also put up links of all the talks like this one that'll be up there for you to look at in the past. A lot of people have asked me like, hey, I know you talked about the HyperSDK or like some release like a couple months ago. Do you remember where that was? And I'm like, no idea. But now I just do it the day it happens and then forget about it. So it's a great way to keep track of everything. All right. Yep.
Awesome. Great call. Okay. Thank you everybody for joining us. We will be back here 2 weeks. We're going to keep the same every 2 week cadence at the same time so that people can get, used to the feel of when they can find us. I'm CG Cardona on Twitter, CGCARDONA. You can also check out Avalanche Developers. That's one word, AVAX Developers. That's our new official Twitter developer handle if you want to kind of stay up to date on what's happening in our developer ecosystem. And you can also join us on Discord at chat.avax.network so you can communicate with us in real time. So we will be back in 2 weeks. Please get your questions ready for the next session. Thank you, everybody. Thank you, gentlemen. Cheers.